In this video, we'll explore nested loops using a series of animations to help better understand their effect on program flow. Before we look into the concept of nested loops, let's do a quick review of how a simple for loop functions. A for loop is a structure in computer programming that allows the program to repeat a task a certain number of times. Take a look at this animation that shows a second hand from a clock. Each movement of the hand represents one repetition of a loop. Think of the numbers being displayed on the screen as a variable that increments by 1 each time the loop is completed. Now let's look at some code that might reflect this animation. Looking at the syntax of a for loop, the code int second equals 0 is how we would declare a variable and assign it an initial value of 0. The integer second is our control variable, and it will determine or control the flow of the program in this loop. The syntax second is less than 60 is called the condition. It is a Boolean statement that determines how many times a loop will repeat. The for loop will continue to repeat as long as this statement is true. The syntax second plus plus is called the update or the iterator. It determines how the value of the control variable second will change after each loop. Without this, the control variable would never change, the condition would always be true, and we would have a situation known as an infinite loop, a situation that we'd like to avoid at all costs. The large number will help us track the value of the variable second. Within the body of the for loop, the code is run once for every repetition of the loop. Each time a loop is completed, the value of the control variable is checked against the condition. So long as the condition remains true, the for loop will continue to repeat. As the for loop starts, the control variable second has a value of 0. The syntax system.out.println second simply prints out the value of our control variable second. We'll illustrate this by outputting this value. Now we reach the end of our for loop, at which point the flow of the program loops around, checks the value of second against the condition statement. As long as the condition statement is met, in this case the value of second is less than 60, then the loop will continue. The next time through the loop, our control variable second has a value of 1. The output statement will print this value and will advance our second hand by 1. Once again, the for loop circles back and checks the value of second against the control statement. Again, the condition is still true. The value of second increments by 1, and the process continues. This pattern will repeat until eventually the value of our control variable second reaches 60. At this point, the condition will no longer be true, and the flow of the program will break out of the for loop. A nested loop is simply a for loop within another for loop. Both the inner and the outer loop have their own control variable. The key thing to remember is that the inner loop must complete all of its repetitions in order for the outer loop to complete one repetition. In this example, the inner loop completes 3 repetitions for every 1 repetition of the outer loop. Once the outer loop has completed its 2 repetitions, then the nested for loop structure ends and the program flow continues. We can use a clock analogy to help visualize a nested loop as well. In this animation, we have a minute hand and an hour hand on our clock. The minute hand will represent our inner loop, and the hour hand will represent the outer loop. Just as in a nested loop, the minute hand must finish a full cycle of repetitions before the hour hand can move through a single cycle. This animation is obviously sped up, but one can visualize how the hour hand moves a single hour for every 60 minutes completed by the minute hand. Now let's see how this works with actual code. Our program begins with our entry into the outer loop. Our control variable for this loop is called outer, and it is initialized with a value of 0. We will place a large graphic to help us keep track of the outer loop variable. This outer loop will continue to repeat as long as the variable outer is less than 3. The value of the variable outer will increment by 1 each time through the outer loop. Immediately upon entering the body of the outer loop, we are presented with the inner for loop statement. Here we will use the variable inner to track the flow of the inner loop, and again, we will use a large graphic to track the value of this variable. This inner loop will continue to loop so long as the variable inner is less than 4. It too will increment by 1 each time the inner loop is repeated. Within the body of the inner loop, we have a system.out.println statement, where the values of outer and inner are concatenated. We'll put these values up on this table to represent the output console of our program. The flow of our program will then return to the beginning of the inner loop statement. Here, the value of our inner control variable is compared to the condition is inner less than 4. As long as this remains true, our inner loop will continue. Each time through the inner loop, our control variable inner will increment by 1 and output a system.out.println statement in the console. This will continue to happen until such time as the Boolean statement inner is less than 4 is no longer true. At this point, the flow of the program will break out of the inner loop, the value of outer will increment by 1, and the process will repeat itself. While watching the animation, see if you can predict what the next output will look like. Eventually, the value of the outer loop variable will become 3, and the Boolean statement outer is less than 3 will no longer be true. At this point, the flow of the program will break out of the nested loop structure, and the program will continue on. Up until now, we have been using the Java programming language to illustrate our for loops. The concept is identical to most other programming languages. In this example, we are using JavaScript to illustrate a nested loop. As you can see, the code is very similar. One item that is not in this code example is the line break that I added at the end of each inner loop. This allows a new row of numbers to be displayed after every 10 cycles of the inner loop. I've also added a couple of sound effects to help differentiate the inner loop from the outer loop. One interesting thing to note about programming in general is the similarities between the many different languages. Once one has learned any concept, such as loops, selection, methods, or classes, transferring the knowledge from one language to another is often very simple. Note how similar the syntax is between the examples we have explored and other programming languages such as Python, C++, PHP, and many others. I hope you have found this video useful and will be able to use the concept of nested loops in your own programming endeavors.